Hello everyone, Ashwini Manjunath here, presenting the final project for Advanced Deep Learning course, the topic being Trip Planning Agent. The primary goal of this project was to develop an AI-driven multi-agent travel planning system capable of generating personalized itineraries, optimizing travel decisions, and integrating real-time travel intelligence. Trip Planning Agent is an intelligent AI powered travel orchestration platform designed to automate personalized trip planning using modern agentic AI systems. The architecture behind all this combines LLMs, RAG, the retrieval augmented generation, optimization frameworks, and orchestration pipelines in order to create an adaptive and personalized travel experience. Agents then in turn exchange contextual information, maintain memory, and dynamically respond to changing user preferences, schedules, and external travel conditions. The multi-agent systems are AI architectures where multiple intelligent agents collaborate to solve complex tasks through coordination, communication, and specialized responsibilities. In the trip planning agent project, each AI agent is designed with a unique role such as itinerary generation, budget optimization, travel research, logistics prediction, and real-time recommendation retrieval. And travel intelligence refers to the usage of AI and real time data processing and predictive analytics to enhance travel planning and decision making. In this project, travel intelligence enables the system to analyze destinations, transportation, accommodation, weather conditions if needed, budgets, and user preferences to generate highly personalized travel experiences. RAG is nothing but a AI framework that combines LLMs with external knowledge retrieval systems to generate accurate, contextual, and up to date responses. In this project, RAG enables the system to retrieve relevant travel information such as destination insights, hotel recommendations, local attractions, transportation details as needed, and travel tips before generating personalized responses. Optimization is nothing but the process of finding the most efficient and effective solution while balancing multiple constraints and objectives. In this project, you will see how we have used optimization techniques that are used to generate personalized travel plans by balancing factors such as budget, travel time, accommodation quality, transportation efficiency, and user preferences. Various approach and techniques that I used, 9 of them, mixing and matching this various combination of LangChain, OpenAI Assistant APIs for orchestration and conversational workflow management, while vector embeddings and ChromaDB enable contextual retrieval of travel information, optimization frameworks such as Bayesian optimization and Optina help balance cost, comfort, travel efficiency, and personalization. Real time travel intelligence is also integrated using live search APIs and external travel data sources. We'll see that one by one now. As you can see, all the 9 models one by one, like each of them focusing either on the high level reasoning or the conversation management or the absolute sweet spot for variables like cost versus travel time tracked by ML flow, then RAG embeddings vector DB in the third model called the researcher, where we used the deep diving into massive datasets, the blogs, reviews, PDFs to find the hidden gems. The mechanism here was to convert the text into embeddings, store them in VectorDB, ChromaDB, and retrieving them in the context for the LLM. Another model, the next one that I used was as for visualizer, wherein I can generate images using the diffusion model as needed based on the mood boards. Then I tried with the logistics engine, basically using neural networks to solve differential equations that predict traffic congestion or the airport security wait times. Model 6 being what I tried was to the end-to-end trip planning agent, which basically generates the knowledge based travel destinations and outputs a structured itinerary. Then I tried the modular agentic trip planner, implementing the mock agent framework using the LangChain and LLM orchestration library. As you can see, we can also give the prompt wherein we can ask the response to be warm and funny, and based on that the results are generated, and also with more details on like the budget stay or the city comfort, and then the top restaurants with the reviews. So it is more modular approach in model 7. Then I tried the global voyager agentic model using the chat open api open AI API, wherein I also gave an option for the user to enter the name, origin city, destination, number of people, and then the travel style, based on which we can combine and collect the uh, information and then plan the itinerary accordingly. And then at the end, I use the real-time web searching agent using the Tavily API, which is the most effective tool as per in 2026. Again, this can take inputs from the user and then plan accordingly with the more detailed approach. Here the difference is we can also provide the list of links wherein the user can further research more as they need by clicking the link, and more details are provided, as you can see here, with the local events and hidden gems and etc., wherein again as needed user can go into research more based on the links provided. Then I tried and compared all the models with the ratings and then the implementation overview. Basically, this project demonstrates that the modern AI is moving away from a traditional trip itinerary um, response or a simple prompt response interaction towards the agentic orchestration. Let's take a quick look on how these were designed and experimented, like creating a new environment, installing the packages, and trying each different model over here by giving the API key and then extracting the detailed itinerary response, as you can see here. The second model, the budget architect, wherein it takes lot of trials and between the hotel cost and the transit hours and gives us the best result. And then the researcher model, wherein we are using RAG embeddings and vector DB. As you can see, the response gives the best visited time and then what to avoid, etc. Then the visionary, wherein we can generate the image based on the prompt, as you can see here. Then the physicist model, which gives airport crowd dynamics, and then the comparison. End-to-end trip planning agent AI model, where it takes the travel data, mock travel data, and then accordingly searches with the input provided and gives our the final itinerary summary. Modular agentic trip planner with more detailed approach and detailed response, with including reviews and then more details on the cost, where to stay, and the nearby activities, etc. The global voyager agentic model. Last two models where I tried to take input from the user in the form like this, and then they can change the number of people and then the travel style, etc. And then once we say plan my trip, it just accordingly gives a output and response. And also I tried using the prompt as be funny, warm, and excited, and as you can see, accordingly, it just does the same. At the end, I tried the real time web searching agent, as you can see, using the Tavily API. Again, it takes the user input and then plans accordingly with according to the prompt that we have given, be funny and warm, and accordingly it gives details. The difference in this model being it also gives the links for the user to further research. The experimented models ratings comparison. As you can see, this project demonstrates that the modern AI is moving away from the simple prompt response interactions towards the agentic orchestration. It was absolutely amazing project to do, to see all the results with various combinations of the AI and how it generates the responses accordingly. Thank you for your time.